Hello, I'm Arthur. Welcome to my lab. Today let's take a look at the Mastech MS8268 multimeter. I'll take this meter apart, see what's inside of it. But first let's take a look at the box in which it arrived. Here's some details on the meter's features, so I'll scroll slowly through this. And again, in this box is used for several different types of meters. In the box I got the set of probes, decent quality, fairly flexible, not too stiff, not the softest I've seen. Actually, so far my all-time winner is the new banana cables, which I mentioned in one of my other videos. But these are fairly flexible. The probes are rigid. Actually, when I was recording video for some other meters, I noticed that some other probes are kind of flexible. Like this one, this is a Victor probe, and see how it bends? I don't know if that's a good thing. Probably not. I don't like this. So Mastech, much more rigid. Decent sharpness of the tips. Shrouded connectors. And the adapter for the I don't know, this is marked CX and K. Is that for K for cathode or K for a temperature probe? The Mastech meter doesn't really measure temperature, so I'm not sure. I haven't looked in the manual. I don't plan on using this adapter because, again, you can't measure temperature with this meter, and for capacitors I'll just use my regular probe. So here's the meter. Power is on. Nice feature of this meter is that it highlights the sockets in which you need to insert your probes. So for the volt measurement, you know that you need to insert your probes in these two. And then if you switch to your milliamp range, not only will it highlight and start flashing the correct socket, it will start beeping at you until you remove the probe and then insert it into the right socket. So that's a nice feature. The only problem with that is that if your probes are a little on the looser side, then they will pop out. Let me grab a set of probes that I have. Those are one of my favorite probes, old school probes that I bought from my microntometer with the alligator clips. Very useful. So these, you try to stick them in, and they aren't as tight as these new shrouded probes, and they just pop out. So you let go. So you can't really count on these making a good contact. And last time I went to Radio Shack, they didn't even have this style of probes. You could probably just buy these clips, buy a regular set of probes, and replace the ends of them. So that's not a big problem, but still a little bit of a issue here. Other than that, the display is nice and legible. There's a dedicated button for the highlight or for backlight, so that's nice, although it doesn't last very long. I wish you could like lock it in, but I don't think you can do that. And your regular set of buttons. I avoid the meters which only have like backlight and hold or the minimal set of features. I prefer to have more options here available to do the measurements. Here's the manual for it, and this is a real legit manual booklet. not just a sheet of paper folded in half, like with Anang or with Holdpeak. So I don't think I'll go page by page through this. That'll be too painful. If you're quick readers or good at pausing your video, let's do it quickly. Hopefully, is this all in English? Oh yeah, no, I'm not gonna go through 30 pages of it. So if anyone is interested in anything in particular about this meter, let me know, and I might just post a picture of that particular page. Here's a table of contents. So here it is. So that's the booklet that it comes with. Now let's take a look inside. This protector shoe is kind of stiff, not as rubbery as with some other meters, and it is a bit tough to pull off. I have to fight with it, and also it doesn't really sit too good. Like when you try to put it back on, it kind of sticks out, doesn't want to snap into its position. Alright, that came off. Here's the foot, and nice that it snaps in place, doesn't flop around. So the meter sits securely, although I don't like this rounded bottom. That doesn't make for a very solid support. And again, can't really turn or operate this meter with one hand. Not on my cutting mat. Maybe with the shoe on, maybe that will make for a better friction, but not like this. But overall, fairly sturdy for this class of meter. Let's see what we have inside. And again, 2 screws here for the battery. And if I remember correctly, these are metal inserts, but I'm not sure if I need to remove these 2 screws. So for now, let's leave them as is, and I'll remove them if I need to. Overall, this meter has this feel of like being more for an automotive use, maybe, you know, for guys who don't really know much about electronics and ICs and stuff like that. It's more aimed at guys dealing with general electricity. Just the feel, nothing in particular that really makes me say this, just the overall feel of this meter. It's maybe more rugged, like it's meant to be just tossed around in a shop somewhere, not be handled gently in a lab. That one last screw doesn't want to come out, so I'm just gonna let it be for now. And I hear the spring of probably the speaker. Alright, this came out, and yeah, so I didn't need to remove the batteries. It looks like these are three AAA batteries with metal contacts here and a metal shield here at the top. So yeah, obviously I put the batteries in, but I just don't remember what they were. So these are AAAs. So that's a nice construction that they have these metal contacts, and then they have springs on the PCB to connect to those contacts. And here are the switches. This is the back of the connector. So as you insert your probe, this switch gets actuated. Oops, the whole PCB popped up. See, I pushed in the probe and the switch came up. So these are just bare contacts here touching this metal pad here on the PCB. Nothing fancy like a push button style switch. None of that stuff. Just bare contact. Here's the high current shim. And probably some, yeah, cut marks to adjust the current. Here's your fuse, ceramic fuse for the high current. It's rated at 10 amp 250 volt, and hopefully that's what it is. It's probably not the HRC fuse like in proper meters. It's just your regular fuse, but just happens to be in ceramic enclosure for better current protection. And a little scroll down the PCB. 2 diodes here. Speaker. And at least this one has an actual chip mounted on the PCB, not just a blob. I'm trying to get the chip number in focus, but I'm afraid that once I focus on this chip, I'll lose the autofocusing. Okay, so Silan or Bilan SC9744, is it? I might take a closer look at it under a microscope or something, just to double check this. 4 megahertz crystal. There we go. That's better. Better light. Some trim pots here, and again, no description. Doesn't really say what these trim pots adjust. And actually this footprint is the same size as the footprint on the Halt Peak, and we have 3 trim pots. Would be funny, oh, here's the 4th one. Would be funny if this was the same chip as on Halt Peak. Connections for the LCD or backlight. So that's the PCB. And again, very little in the way of protection. Not really too big on protecting here the circuitry. I'm pulling out this PCB, and there are 2 clips here on, oh, let me refocus. So there are 2 clips here holding something. I think they actually seem to be coming up along with the, yeah, so this must be one assembly. There are 2 screws here. That's probably for the rotary switch. 2 screws here. And I think this PCB is just sandwiched between the back enclosure. Maybe it rests on these posts here, and maybe on these tabs here. I think that's all that holds this PCB in place, and these 2 screws here. And this part here looks like it's a blank that in some models is removed, and you probably have a PC interface here. So let's remove these 2 screws and see if we can remove the PCB out of the enclosure. And I see 2 tabs here, so I'm hoping that the LCD is attached to the PCB, so I won't have to fight with that connection for the LCD. Okay, 2 screws are out. Trying to wiggle the PCB out of place. Yep. Okay, I made a little bit of mess with these shrouds here. These are like light ducts that deliver the light from a LED on the PCB here to the front, so you can see that that light. And it looks like they have these little notches in them, and those notches go in tabs here. So that's how you orient them in the right position. There we go. And these are the push button contacts. Looks like there's carbon layer on them, so probably your typical PCB connection pad. So let's flip this over, and yeah, that's a very nice front, very nice assembly. Won't fly apart on you. So here we have the connectors. If I can get this thing to focus. There we go. Not really much to look at. Here's something. It looks like there may be a push button switch maybe in some models here, or maybe a photo sensor like in Hold Peak, but there's nothing here other than a little circle, which means that maybe there's a version of this mold that has this opening here for a switch or something. Here's the selector assembly, and I'm looking under this cover, and looks like there's really nothing exciting under it. See, it's all just flat PCB pretty much, so I'm not gonna bother popping this off because there's really nothing to look at here. But overall, I like how they made this whole assembly that is much more secure and reliable than some other meters. And this daughter board with the connectors, there's some stuff here, so let's take a quick look. I think this might be a microchip here. So they use this microchip PIC let's see if we can read. There we go. PIC 16F54. So they use this chip to read the switches and turn on the LEDs, and I think send signal to the beeper. That's how they do that cheater circuit that tells you where you need to plug in your probes. And here's a fuse, I'm guessing for the milliamp circuit. So again, split side connectors, but at least these are like one piece of metal, not just a leaf of metal wrapped around. This is like more proper than in the cheapest cheapo meters. And I wonder how they keep these from rotating out of place. Maybe that's why this ridge here is to keep them, yeah, looks like that's what keeps them aligned. So that's pretty much all there is to this PCB. If anyone has any info on the chip, please post your comment. Give us a link to the chip, to the data sheet. I'll try looking for it as well. Nothing fancy going on. No op amps, no EEPROMs. I wonder if there are any special features that could be enabled with some additional circuitry on this chip. Probably the same chip is used throughout all of those meters that were shown on the box. Maybe we can enable some extra features on this meter. Although this is pretty much top of the line version for the 4,000 count meter. The other meters, there was one other meter here listed on the box that is 22,000 count, I think. 20,000 count. And so this meter here, which I'm showing you, is 4,000 count, and the other 3 meters are only 2,000 count. So this is pretty much top of the line for this range, and the next step up would be 20,000 count. So that should be it for today. Hopefully I've covered everything. If there's anything else that you'd like to see about this meter, let me know. Talk to you later.